A major discovery deep in the interior of Earth, scientists have found the remains of an ancient separate planet. And I cannot stress this enough, this is one of the most important geologic discoveries in the last 30 years. If it is confirmed, this discovery would seemingly fill in the gaps in so many unknowns and open-ended questions scientists have about our planet's geology. At between 2,200 and 2,700 kilometers depth depending on location are two very large masses LLSVPs of unusually dense rock right outside the upper boundary of our planet's upper core. These two blobs are known as large low shear velocity provinces, and represent the remains of a planet known as Theia. 4.53 billion years ago, this protoplanet, which was approximately 90% the diameter of modern Moon formation day Mars, collided with Earth, pulverizing much of our planet and ejecting large amounts of material into orbit. This ejecta, involving material from both planets, then largely coalesced in orbit, forming our planet's moon 4.53 billion years ago. Yet, not all of Theia was pulverized, as sections of this ancient protoplanet's mantle subsequently sunk deep into Earth due to the fact that it was denser than Earth's overall mantle. This increased density can largely be attributed to Theia's mantle fragment being enriched in iron oxide. Over time, two large fragments became emplaced above the upper core boundary in what is now location of LLSVP's West Central Africa, far beneath Cameroon, and in the Pacific Ocean beneath the nation of Kiribati. If I now overlay the outer boundaries of these denser Theia remnants along with Earth's most active known or suspected mantle plumes, commonly referred to as hotspots, you will note that there is a very strong correlation between the two. Specifically, all 10 of our planet's most currently active mantle plumes are located in these regions, despite the fact that they only encompass 24.9% of our planet's surface area. Speculation. I want to note that everything said from this point forward in today's video is pure speculation, but it presents fascinating possibilities. In other words, it appears that the remnants of Theia, which had a different composition than early Earth, are somehow being used as the foundation of Earth to directly form the most intense mantle plumes. Link to mantle plumes? One potential explanation why this is seemingly occurring relates to the increased temperatures the large low shear velocity provinces have. Due to their temperatures, they would heat adjacent batches of nearby mantle material, causing a threshold to eventually be reached where it expands to such a degree due to an increase in temperature that it would travel upwards. However, there are even more fascinating implications regarding these ancient planetary fragments. Plate tectonics link? For one, this ancient collision where the 6,100 km wide Theia collided with the 10,900 km wide Earth may have provided the initial kick needed to create what would become Earth's plate tectonics. The rising material from early mantle plumes would push the crust upwards and outwards slightly, causing increased strain at regions which experienced compressive forces from the two large low shear velocity provinces on each side. This caused sections of the crust to become dense and thick enough that it finally dripped downwards, falling into the lower mantle in what is known as a lithospheric drip. This downward motion and the circular convection it ended up creating likely led to the eventual transition to true plate tectonics several billion years ago. Yet, if this truly did begin plate tectonics on Earth, why did a similar scenario on Mars, a Mars problem where a massive impact scar covers 40% of the planet, not cause the same process? Although this is still an open question, one possibility is that the impacting body which created Mars's Borealis basin was too small, only being 2,000 kilometers wide, or had a composition too similar to that of early Mars to have generated the amount and strength of convection necessary for plate